Hello again, y'all. So for today, I actually did a lot of writing about the beginning of the universe and also my beliefs and what I think of um, about things like God and the Tao and the existence of the universe and of our existence here and the beginning of everything. Not even the beginning of the universe, because a lot of theories nowadays is with quantum mechanics uh, and string theory, which I don't understand at all. But a lot of those scientists are allowing for the possibility for multiple universes and for something like the eternal inflation theory. So, uh, before we get into the eternal inflation theory, we got to understand the inflation theory. And before we get into the inflation theory, we got to understand the Big Bang. So, from my understanding, the inflation theory is this: whenever the Big Bang happened, there was a huge burst of energy at the very start. But what happened is that uh, it expanded so quickly and bigger than our known universe observable universe, and also probably bigger than that, and then cooled and condensed in certain spots to start our um, forming the galaxies and the stars and that, well, first the atoms and then up from there. So it wasn't necessarily, it went out and kept expanding, but it boomed past our borders that we know of right now, and then settled down to cool. And I want to understand a little bit more of that theory, because we do know nowadays from science as well that the universe is expanding. So, and it's this dark energy that is expanding it, because with the Big Bang Theory, you would think that this burst of energy would, uh, because of motion and of physics, with a object in motion will keep in motion unless acted upon by other forces. Well, the Big Bang exploded with all this force, and now other forces are acting upon it. Well, actually, it's weird you say that too, because there was no, at least from what I researched, there was no forces to act upon the Big Bang when it burst into existence. There was no, they actually, all the forces as we know right now, like the strong force and weak force, which I don't understand, but I know they're forces. Electromagnetism and gravity were all postulated to be one unified force, or not even seconds, like 0.00000000. It was like 10 to the negative 16th. Is they were all one, and then they spread and between like 10 to the negative 16 to 10 to the negative 8, something somewhere around there. So what happens if there's no forces to act upon a universe that is expanding? um I haven't done research into that. I don't understand, but that might also be a reason why um, the universe expanded as quickly as it did, because there were no forces acting upon it when it first exploded. And how the inflation theory could take place. Now, we don't understand what dark energy is, which is the force that is pushing the universe away from each other, or spreading it apart, or pushing it apart. But we also don't know what dark energy is, which is the mistress matter that is pulling pulling galaxies into formation. It's kind of like a halo of gravity around these galaxy clusters to keep them from spreading apart. Think of it like a atom or a molecule. So with a molecule, why it keeps within itself often doesn't spread apart is the molecular forces and chemical forces that are acting upon it. So think of dark matter in that sense, is that, but just with galaxies. And that's what's interesting about it's so mind-boggling. It's mind-boggling how just interconnected everything is, or it seems to be, because you have this almost this microscopic entity is atoms, molecules that have this force that is keeping them in check together, molecular and chemical forces, keeping the bonds and keeping the molecules all from spreading apart. Yet you have that on the cosmic scale as well. It's just that dark matter, we just don't understand it at all. We don't understand why these galaxy clusters have this dark matter around them, and that dark matter has such gravitational force to keep these galaxies together. But it's very similar, or it seems like, to atoms and molecules. And that just seems like another interconnectedness to the universe. Maybe a principle that the universe follows. Maybe not a rule, but a principle that it follows, that there's certain forces enacted in place to keep certain forms and systems in order. But it's just interesting. So going back to the Big Bang, the Big Bang. So you have this inflation period where it spreads out really quick and then cools down. Well, the eternal inflation theory is at time zero, and this is postulation. These are pretty much guesses. This is guesses because we don't have any right now. Science doesn't have any laws. There's Newton's laws, Einstein's theory of relativity, and quantum mechanics don't explain what happens before, I think, 10 to the negative 36 seconds before after the Big Bang. Because from how it was explained to me, before that time, all our known tools for, or those three tools, Newton mechanics, Einstein's theory of relativity, and quantum mechanics, they don't work. They don't. Mathematically speaking, they don't work. So everything I'm about to say about time zero is just speculation. We don't understand. We don't know. But one theory I find that was interesting is this eternal inflation. where think of it kind of like a lava lamp. That's how it explained to me. And there's this lava, the lava inside, big old blob, and our universe was one of those blobs that not peeled off, but plopped off. And that plopping was the Big Bang shooting into existence from this internal inflation that keeps going on and on and on and on and on because as the lava lamp keeps spreading itself out, keeps slogging off, slogging off. But in the universe or sense and the multiple universes, it's not that and you have a limited supply. It just keeps expanding and growing and doing this. It's an interesting theory. I like the theory in regards to how organic it is, because life in the universe is it's practically an organism on itself. We are able to predict and we are able to calculate and we're able to put laws and rules from science onto the universe. But then the end of the day, those are all approximations and they're all patterns to what we see in the universe. And since they're so let me kind of explain that. So gravity, for instance, we understand that gravity is a constant within the universe. That's how large objects affect each other, through gravity. And that's how we stick on this planet, is through the gravity. But within our calculations, we do a rounding of gravity because it's close enough to be able to do the calculations. But I would assume, maybe I'm wrong with this, even wherever you are on Earth is going to have a different gravitational pull than the spot you have now. And it kind of makes sense because look at the moon. The moon has a gravitational pull, and that's how the tides work. And so it stands to reason that you're going to have a different and different forces, gravitational forces, affecting you in different places or gravitational constants at different places. So, the 9.14, that might be consistent. But whenever you go past that decimal, it's going to be different because you're in different spots on the not universe, on Earth, and each spot on Earth has a different specific number to it that can never be properly calculated. But for our purposes in science, we're able to round it to 9.14 because, well, that's the average of the Earth. And it's so big that the small little, it's so big that you in this place and you on another place on Earth, the gravity is going to be so minusculely different that it doesn't matter in that point if we say 9.14 or 9.1 or 0000 blah, 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 all the numbers afterwards. So yeah, it seems like that's why I like the theory of eternal inflation, because it acts organically. It's something that's organic. And I think moving forward in our scientific endeavors, I think it'd be prudent of us to, yes, think mechanically, but also think organically, to incorporate biology in how we understand the universe, and also think mathematically as well. So you have the mechanisms of this life, but you also have organisms and organic processes in this life as well. So I think it'd be helpful to think that the beginning of the universe would incorporate something of this similar light, something that had, has a consistent pattern to it, but is wholly organic. That each lava lamp and lava in the lamp is going to be different from the other lamp, but it's the same consistent pattern that happens. So, yeah, it's just interesting things, interesting stuff. I'm not a physicist or cosmologist. I think that's what you call it. It's either that or cosmologist is the one you put makeup on and stuff like that. Or astrophysicist. So I don't know. I not in the weeds of this research. I'm basing it off of what actual astrophysicists uh, uh, and scientists have come up with. And for me, I'm going to have to trust in their research and their computations and their judgment. But from what I've heard and from their background and from their research and understanding and reasoning, I'm okay trusting it. And that's kind of how I feel as a philosopher, is that, and I have to understand, I feel like I need to understand the basics in every single field so I can make those connections, but I have to be careful with the people I do listen to and I do read, because that's how that's where I'm going to get my basics from. And if I'm finding someone who's not talking about the basics, who's doing wild postulation theories, then I'm going to mess up my thinking as well. So I hopefully I'm doing a good job of weeding out the people who are not, let's say, experts in their field. Yeah. But that's fun stuff. It's good thought-provoking material. And well, I'll see you guys tomorrow. I'm going to San Antonio, so you'll see me somewhere different. Exciting times. Bye.